Okay, so now we're going to go ahead and talk about how to find the moment of inertia of an object that is not just a point mass or just a shape, combining those couple of ideas. Okay, so let's look at this object below. So first thing I always look at when I'm trying to find the moment of inertia is I label really clearly what the rotation axis is. So we have a pin, and this object, let's just say it's hanging in the air. There's a horizontal rod, and attached to it is a 200-gram mass. So I'm going to label this right here is my rotation axis. So that's where everything would want to rotate about. Okay, so let's look at this. How many shapes do we have? We have two shapes. So the total moment of inertia, I think it's kind of in a way like total mass. It's the rotational analog for mass. So to find the total mass, I would always need to add. So to find the total inertia, moment of inertia, I need to add as well. So moment of inertia, I'm going to say I total is going to be the moment of inertia, of the rod plus the moment of inertia of the hanging mass. Great. So now let's look at a rod. So this rod is rotated about the end. So I can look at my handy dandy moment of inertia table. I know a rod rotated about the end is 1/3 ml squared. And the mass is going to be a point mass. So it's some little mass rotated some distance from a pivot point. So that's just going to be mr squared. Great. So now let me go ahead and plug everything in. So the mass of the rod, and I'm going to make sure my masses are in kilograms and my lengths are in meters. Mass of the rod is just 3. Length of the rod, 60 centimeters. That is going to be 0.6 meters. So I'll put that in. 0.6 squared plus the mass of the point mass. That's just going to be 0.2 kilograms. And then the radius, and again, radius is the distance from that mass to the pivot, which in this case is 0.6 meters. Great. Great. So I punch this all in my good old calculator, and I get 0.36. I guess I could have done that without a calculator for the first one. And then 0.072 for the second one. So when I add those together, I get 0.432, and my units will be kilograms for mass, and length or radius are measured in meters, so kilograms meter squared. Great. So I think about it, if you add a mass to the end, that increases the moment of inertia of the rod pretty significantly, so it makes it harder or more resistant to changes in motion.